All right, so we'll just go ahead and start. Today, I do want to make sure that it's working here since we didn't have any intro here. But today is exam 2. It opened at midnight this morning. The instructions and starter code were sent out via email and are available on Piazza. You submit your source code through the web hand-in as usual. Today is lecture, but we'll be doing a review. We'll have our regular, or sorry, there is no regular hack session today. That was a copy paste there, but of course, no collaboration of any kind is allowed on the exam. Good luck. Any questions before we start on the review? No? Okay. Post with any issues on Piazza if you have it. Otherwise, the form of the review is going to be like I've been doing for the last couple of days in other sections, is going to be us looking at Advent of Code exercises. So for example, this is a website that started 8 years ago, and they've been doing it every December. It's an Advent calendar, but with code, right? So each day, a new one opens up, a new problem opens up. In fact, there are 2 problems each day. They're based on the very, very similar. The first one is pretty straightforward, and the second one is a little bit more challenging with the same data, the same input, such that if you do a well-designed solution on the first one, the second one should be pretty easy to do. If you just throw a solution at the first one, then the second one is going to end up having to be a little bit harder. This is the one from 2015. I completed it. I've completed several of them. 2016 looks like I gave up or something. 17, 18, maybe I was bored, I don't know. But I've been using these as reviews in this course because of in the fall, because it's relevant that it pops up every year, and so nice little programming exercises. The one I've chosen for here is day 1. They do get progressively harder. So the second day is harder than the first, the third day is harder than the second, etc., all the way up to the 25th day. In 2018, day 1, there's always some sort of a story to go along with it. We're going to skip that because I don't really care about the story. And let's go down here to get the puzzle input. So what the puzzle input looks like here is a bunch of numbers, 1 to a line, integers, right, with positives and negatives, right? So the idea here is that you're computing some frequency. You're always trying to save Christmas somehow, right? So, or save Santa or something. So for example, let's see, let's look at the first part here, sorry. So if your input looks something like this, right? +1, -2, +3, +1, then you start out at a frequency of 0. It's a radio frequency or something, who cares? The first input here is +1, so your resulting frequency is 1. Then the next frequency is -2, so you go down 0, -1, right? That's the result. And then up 3, so from -3 you go 1, 2, 3, and now you're at 2, right? So get the idea? Right. So let's go ahead and grab my input over here, and it's not that big, but it is definitely not trivial, right? I don't know how big it is. And then at the very end, we've got a very, very large number. Not a very large number, but another number there. The input is randomized and probably individualized, right? So for example, here there are 967 lines to process. Okay. So let's come over here to C, and we'll redo this in Java if we want to. Let's do this in C though. So if I put that into the input file, what I'm going to want to do is open that up and process it line by line by line. Now, of course, if I had my hack 10 done, that'd be easy, right? Just cut, paste the code, and use the code, which is what we want you to do in your exams and other assignments, right? The strong hints there that in hack 10, you were supposed to use hack 10 and hack 9, and that protein sequencing should have been like 8 lines of code, and that's it. Right? So let's go ahead and go through the file processing now. But I'll start, as a review, I'll go ahead and start from scratch here. Right? So to open the file, it's going to be fopen, right? And we're going to read this in as a command line argument, right? And we're going to open it up for the purposes of reading. I generally like to immediately close it so that I don't forget to at the end. Right? and then return 0 here, okay? Now, how many lines are in there? Well, I could cheat and say, oh, well, there are only 967 lines. So I'll go ahead and create an array, an integer array, numbers of 967, right, of size 967, and I'll go ahead and write a for loop that only operates on the file 967 times, reads 967 lines. I don't like that, right? That's bad design, okay? So let's go ahead and process the file line by line by line. Now, good design would be getting my hack 10 done and reusing that code here and not having to worry about it ever again. But I don't have my hack 10. So let's go ahead and do that exercise where we're getting each line of the file, right? To do that, I will need a buffer, right? A character buffer, because I'm going to be reading line by line. I'll go ahead and make it of size 1000, which is ridiculously large for any one of these lines, but it's not big enough to have a concern for Stack Overflow, okay? And then I will also want a pointer, because I'm going to be using fget what? To read line by line. Fget s, right? And I'm going to read into buffer at most 1000 minus 1 characters, because it takes care of the null terminating character for me, from f, right? And then because I don't know how many lines, or I'm not going to assume how many lines are in the file, I go into a while loop. While the line is not equal to, how do I determine if it's the end of the file when I'm using fgetS or forgets? Would it be ELF? No, that's fgetC, right? And that's a character. It would be null. Right? So while that's not equal to null, I'll go ahead and read another line. Line is equal to fgetS of buffer, right? 1000 and f. Well, that reads it line by line by line by line, right? But what do I need to be doing with those lines? I need to be converting them over to an integer and probably keeping track of them. Now, I could be, I could be quick about it and say, all right, well, I'm just going to read the line, -15, so we go down in our frequency 15. Throw that away. Now I read -17, we go down 17 in my frequency. I'll throw that away, right? But that will probably screw me for the second part, which is always going to be a little bit more difficult if you design it incorrectly. So what I want to do is I want to load up all of these numbers and put them into an array, because I want to keep that data, and I want to probably want to process that data later on. So if I don't know how, what I could do is I could, of course, just immediately convert this. Int x is equal to a to I of buffer, right? And then update my frequency. I don't know, int frequency. It starts at 0, and then frequency plus equals x, right? And I would probably get the correct answer. Printf ending frequency is equal to %d and the line, ferq. Right? Let's go ahead and try this. I will go ahead and use the wall flag on 2018.01.c. There we go. Right, and run this on 2018.01 input. There we go. Ending frequency is 435. I got it done quickly, right? Let's see if that was a correct answer. Hey, there it is, 435, right? All you have to do is sum up all the numbers. Right? And by the way, what does that tell you about a to I when there's a plus in front of it? It interprets it correctly, right? Plus 12, plus 3, right? In fact, a to I would allow you to use, or a to f actually would allow you to use scientific notation, right? And a couple of other formats. So I got it done, but my short-sightedness and get it done quickly is now going to screw me for the second part, because to calibrate the device, you need to find the first frequency that it reaches twice. So for example, if it reaches frequency 42, right? That's the first time it reaches it. And then it goes up, down, or whatever, and then comes back down eventually to 42. That's the second time that it happens, and that's the frequency that I want, 42. I don't want the ending frequency. I want the frequency that it first reaches twice, okay? So I've painted myself into a corner here, right? I'm not going to be able to do this because I need to keep track of all, well, I could keep track, I need to keep track of something additional, basically, okay? And that thing that it's additional is the number of times that you've hit this frequency, right? Up, down, whatever. Note that it's going to be sometimes negative, sometimes positive. Do we have a bound on an upper bound and a lower bound on it? Nope. In fact, that's probably why they gave you this ridiculously large value at the very end in order to break your assumption about, oh, well, there's only 10, 20, 50, and there are only 900 of them, so maybe 1 million at most, right? That would actually probably work, right? But I don't know. We can cheat, I guess, right? Ideas, though. So instead of just simply putting this into the buffer, or putting, keeping track of each value, let's go ahead and keep track of all the values, right? So to do that, of course, again, I could hard code 967, right? I don't want to do that. Let's go back, and instead of doing this all at once, let's go ahead and count the number of lines. Int num lines. I'll start that out at 0, and instead of immediately reading them, I will go ahead and count them up. Num, oops. So I get the first one, right? That's 1, num lines, plus, plus. I get the next one, the next one, the next one, the next one, et cetera, et cetera, et cetera. Right? Now that I've counted lines, in fact, I'm going to even completely redesign this one right here. I no longer need to use a while loop, do I? I know exactly how many lines are in there. So for int I equals 0, I is less than num lines, I plus plus. What I'll do is I will read the line, convert it over to a value, right? Compute the frequency all at once, just do this the same thing again. But then I'm also going to put it into an array of numbers. Numbers, so I is equal to x. Okay? To do that, of course, I need to set it up. Int star numbers is equal to int star malloc size of int times, and how many do I want? However many lines there were, because I went through and I counted them once. Now looking at that code, is it going to work? I've read the file once to count up the number of lines. Now what do I want to do? I want to go back to the beginning of the file and read all those lines again so that I can convert them over to integers. Where is the file at this point on line 22, on line 23 though? It's at the bottom. How do I go back up at the top? The solution that we were kind of expecting most people to do would be to close the file and open it up again, right? Is there a lot of people went the extra mile or the extra couple of steps and actually RTM'd, read the documentation, read the manual, and they found a nice little function called rewind, right? It's called rewind, and there's also functions called like fseek, and a couple of other functions maybe. It's called, it's using this terminology because when it was created, everything was stored on magnetic tapes, right? The big giant tapes where you would rewind it or fast forward it or seek through it, right? And so it's using that kind of terminology, right? To this day, you're familiar more with zip files, right? Where you can take a whole bunch of things and zip them up and compress them. On a Unix system, what you generally do is you tar them up first. You create this what's called a tarball. You grab all these files and put them into one archive file, and then you compress that one file. Right? Tar stands for tar. They're called tarballs. Okay, whatever. TAR is going to stand for tape archive. Tape archive, right? To this day, even into 2022, at a cost of per megabyte, magnetic tape is still the cheapest way of storing data, right? All right, but I've rewound all the way. Do this again, and let's see if I broke anything, right? I should still get 435. Great. But now I can actually do the second part of that day, right? Where I want to find the first frequency that it reaches twice. To do that, I'm going to have to keep track of all previous frequencies. Right? I could set up a big giant array with, okay, frequency 5, I've reached that 0 times. Frequency 8, I've reached that 0 times. I could have this big giant array, right? Where and then every time I hit a frequency, I increment that counter, increment that counter. But again, I don't know how big they are. Right? And they're going to throw me for a loop way down here at the bottom when they add this big number and force me out of my my indexing. Right? So, ideas? Yeah.
Put all of the numbers into an array and then check each time to see.
What numbers are we talking about? So the numbers are in an array, right? The numbers from the file.
Yeah, and then every time that you take in a new line, you ferment a number and check to see if it has been in the array before.
Well, not that the previous frequency, like I don't care that plus 12 was there. That's a change in frequency, right? I want to know, did I hit 42 twice? In fact, let's look at the example here, right? Here are other examples. Negative, plus 1, then 1 reaches 0 twice because you start at 0. And then you go up, and then you go back to 0. Plus 3, so 3, 6, 10, 8, 6. Wait. 3, 6, 10, 8, 4 reaches 10 twice. What? I don't get that one. Help me out on this. Maybe I'm misunderstanding it now. I didn't completely read it. 6, 10, 8, minus 4. Let's read this one. So, negative 6, plus 3, now I'm at negative 3, plus 8 would get me to 5, right? And then 5 up, and then reaches 5 twice. I don't see that it hit 5, did it? It hit 5 once, right? Negative 6, negative 3, plus 5, plus 10, 4 is what I get. Maybe it means passing. Ah, crap. Okay, so let's read this fully. Current frequency is 0, changes to frequency 1. Current frequency of, okay, repeats the same frequency change list over and over. To calibrate, you need to find the frequency it reaches twice. For example, using the same list above, the device would loop as follows. You go from 0 to 1, okay, 1 down to negative 2, or negative 1, right? Ooh, wow. So it's not, because you just passed 0 twice. You passed it. You didn't land on it. The first frequency reached twice is 2. Why is that? So let's write it out. 0, then 1, then negative 1, then 2, then 3. Oh. At this point, the device continues from the start of the list. I didn't see that, did you? Because we're already out. Ah, there. So it repeats and goes back and forth and back and forth. Now, understanding that, let's go ahead and read this second one. So plus 3 plus, so we go at 0, then 3, then 6, then 10, then 8, right? And then negative, or 4, is that right? And then it repeats, so plus 3, 3, 4, negative 2, and negative 4. All right, so now we're back at 3 here. So where I was at 4, so we go up to 7, and then we go to 10. Oh, there, where we hit 10 again, right? So the list repeats. All right. Now I'm glad that I put it into an array. Right? We all understand it now? I think I understand it. Let's find out. At least I understood it 4 years ago because I got the right answer. Wait, 234, 245, okay. All right, I can kind of see that. Now I will need a counter, right? All right, let's call it int hit frequencies, okay? And what I'm gonna do is I'm just gonna make this really, really large. Malik, if I made it really large, like 10 million integers or something like that, right? When we go down to negative indices, we're gonna have to be very, very careful, right? So let's just make this large, size of int times 1, 2, 3, 1, 1, 2, 3. There we go. And I'm also going to do a trick here. Actually, let me go ahead and put this into a variable n, right? Int, and I hope that we can get this done quickly because I'm going to show this to you in Java again, and it's going to be way easier because we're going to use a smart data structure to do it. For int I equals 0, I is less than n, I plus plus. I'm going to go ahead and go through and initialize everything to 0, hit frequencies, so if I is equal to 0, right? And then I will say that hit frequencies of n divided by 2 is equal to 1. What am I doing there? Right. Remember that we're going to go down to negative values over here. Negative 2, dot, dot, dot. So if there are a million things here, 1 million, 1 million, right? Then I can't have negative indices, can I? So what I'm going to do is I'm going to suppose that this is, instead of, this is going to be 0 up to n. So what I'm going to do is I'm going to assume that this is n divided by 2 at 0, and then positive values go up, right? Positive and negative values go down. Do we understand what I mean? So that when I have a hit frequency x, or y, say, or FERQ, right? Then if that value is positive, it'll appear in the second half of the array. If it's negative, it'll appear in the first half of the array. And all we're going to do is use this as an offset here. In fact, I'm going to put that into a variable called offset. Int offset is equal to n divided by 2. And then just use that and make sure that I'm going to off of that offset there. Okay? Offset is going to end up being 0, right? And so that offset plus 1 is equal to 1, offset plus minus 2 is equal to negative 1, et cetera, et cetera. Right? All right. Go through it again, right? This is a different problem, so I'll go ahead and get rid of this. I'm just reading the numbers in. And now I don't know how many times I'm going to go through the list, right? So I'm going to now go into a while loop, while true, right? And I'm going to go ahead and get rid of that. Right? I will start with my index, int index, or I, at 0. And what I'll do is my frequency will also start at, int frequency will start at 0. Did I already do that up there, though? Oh, yeah, I did. Okay. I want it closer to the action down here, right? So I've got my I, my index, my frequency. And what I do is I change my frequency based on whatever is in numbers sub I. Right? So there's my change in frequency. And now I need to update the hit frequencies of offset of plus frequency plus plus. Do you see the trick I'm doing there? Maybe this is an obtuse way of doing it, but this is the quick way of doing it, right? So suppose that the offset is, say, 500,000, right? And the frequency is 0, right? Plus 0. Then I'm incrementing that, right? Now I've already set that equal to 1 because I start at the 0 frequency, right? So whatever that index is, I increment it by 1. That means that I hit that frequency again. Now, check it. If hit frequencies of offset plus frequency is greater than 1, that means that printf first frequency hit twice is %d end the line, and whatever that is. Okay, I'll get rid of that. Now there's something else. Oh, and then of course I need to increment I, but I need to be careful here because this is an array that I'm going back and forth, back and forth, back and forth on. So when I gets too big, what should I do? I plus 1. Remember that there are only, what, 967 of them? So how do I go back to 0 once I've gotten to the end of the list of numbers? Mod num lines, right? However, that's the size of the list. Okay. And I'll go ahead and exit 1, just so that I only get one piece of output here. That's not the best way of doing it. Probably the best way of doing it would be to simply just break out of this loop. Oh, and I should probably close it after I'm done processing it, right? Up here. Oh, here. There we go. So GCC, oops, x, oh, a to I of buffer. Got rid of x there. There we go. Well, okay. There we go. First frequency hit twice is 2. Uh-oh, that's wrong. That's definitely wrong, right? Well, okay, that's the actual frequency, sorry. Of course that's 2, right? That's how we got that it's greater than 1, right? It hit it twice, it hit it 2 times. That's not what we want. What do we want? The frequency that just caused that to happen. There we go. 245. I think that was the correct answer, right? Yeah, 245. All right. Kind of convoluted, but that was the quick way of doing it. I wanted to reach the leaderboards or something, right? There are leaderboards here. Typically, you need it opens at midnight, or Eastern Standard Time, so I guess 11 p.m. So you have to, immediately get there and see it open. You have to code it in a matter of minutes, literally, because the leaderboards are all like 1 or 2 minutes. People that get it done that way. Right? It took us 27 minutes here to do both of them. Right? And that was meaning that I misunderstood the problem here, right? So, before we go on here and look at a Java solution, do you see what I did? Right? That the frequencies were going positive and negative, but I couldn't put that into an array, right? Because the indices only go one way. So what I did is I said, okay, well, this range here, I'm going to map that down to from 0 to, I'm going to map a range, say, of, let me get rid of this. I'm going to map a range of, say, -10, ... 0, ... +10, right? So a range of 22 things. What I'll do is I'll map that down from 0, 1, 2, ... 20. Right? I've mapped those down by using that offset. Is equal to 20 divided by 2. Right? So that when I go 10, -10, and add that offset, I'm now at 0. When I'm at 0 and I add that offset, I'm now at 10. When I'm at 10 and I add that offset, now I'm at 20. So that was the trick that I used. Okay? We don't have to use tricks over here in Java at all. First of all, as a review, let's open up that file. I'm going to go ahead and grab the contents of this file right here. There we go. And create a new file. New. I'm just going to call it advent.txt, since we're only doing one day here. There we go. I want to open up that file and process it line by line by line. What is the easiest way to grab the entire contents of that file in one go, period? Use my library from Hack 10, but my library from Hack 10 probably should have been one line of code, right? because I think I showed it in class even, right? Java NIO read entire line, one-liner to Java, right? In fact, there it is. That's a current line. No, I don't want that. Read all lines. There we go. Steal that code, put it over here. Right? And that's not my path. My path is going to be data/advent.txt. Right? Do not do that. It's a list of strings. Right? Read all lines. I don't want to print them. I want them. And don't print the stack trace. Throw new runtime exception on X, because I'm not going to handle that exception. Now let's print that out, right? System.out.println contents. There we go. System, and to do that I want to move this outside of that try catch is equal to null. There we go. Put that there. System. There we go. So here are the contents of that file. Right? Remember, I think that this removes all the end-line characters, right? I decoded the lines from the file, therefore not specified. All right, it's not telling me in this, but from the output here, it is clear that it is not keeping those end-line characters. Right? This is all what get file lines should have been. And that's it. Right? Okay, so let's not print out the contents. What I want now is a list of integers. Right? I want to convert all those strings over into integers. Here's the there's a more modern way of doing this with closure, lambda expressions. I'm not going to go there because I don't want to, I'd have to look it up anyway. I don't know how to do it off my top of my head. But you could do this in one line or two, right? You could convert each line into an integer with one line of code using lambda expressions. What I'm going to do is I'm going to just say numbers. Numbers is equal to new array list of integers. And then for string s in contents, I'm just simply going to say numbers.add integer.parseInt of s. There we go. And now let's print that out. System.out.println numbers. We're going to get the exact same output here. It's just that it's going to look a lot different. For example, those pluses are not going to be there now because they are actually numbers that are being stored in that list. Right? Let's make sure that it's correct by looking at the last one. 125143. That looks familiar. Right? Okay. All right. Now what do I do? Well, for the first, for the first day, what I would do is I would run through each one of them. I do not need to keep track of any indices here if I'm going to use an enhanced for loop, right, in numbers. Right? And I will have a frequency here. Frequency is equal to 0. And I will simply just change the frequency plus equals x. At the end of that, system.out. Println final frequency is frequency. There we go. Right. So running this, I think it was 235 or something. We'll look it up here. 435, sorry. And indeed, that was the answer on day one, 435. Right. Now, this trick that I did here, right? Let's not do that. Right? Let's use a smart data structure, a map, right, of integers to integers. Right? All right, frequency map is equal to new hash map. There we go. Now the idea here is that this will map a frequency to the number of times you hit that frequency. All right? So for example, I will start out by putting into this map frequency map dot add, or put, sorry, 0 maps to 1. Why? Because when I start out with a frequency, in fact, I'll have to reset it here. Right? When I start out with a frequency of 0, reset it, There we go. That is hit once. Right? Then I'm going to go up and down and up and down and up and down in a while loop. Right? Here I will have to use a traditional while loop, right? While true. And a traditional index, int index is equal to 0. Oops. There we go. And what I'm going to do is I'm going to get the ith frequency, right? So frequency will be updated to frequency numbers dot get I, or index. Make sure that I set myself up for the next iteration. Index is equal to index plus 1 mod the size of that numbers dot size. There we go. That all so far is just a straight up translation of what I just did in C. Right, I'm going to go over that list over and over and over again. When I get to the bottom of the list, right, I go back to the top of the list. Go over it again, go back to the top of the list, go over the, et cetera, et cetera, et cetera. I'm changing the frequency. But now what I need to do is I need to check, right? So old count, right, into, and I'll show you here what I'm going to do. Old count. I'll get out of that map, frequency map, dot get, whatever the frequency is. Right? That will tell me how many times that frequency came up. Why did I use a big I integer? Because what if this is the first time that I've seen that frequency? Right? What the frequency map is going to do is it's going to return null. Right? If old count is null, this is the first time that you've seen it. First time we've seen FERQ. And so we handle it differently. What do? We go frequency map dot put frequency maps to 1 because we've seen it now once. Right? Just like I did up here. We've now seen 0 once. Right? Else, it's not null. That means that we've seen it before. And the old count tells us how many times we've seen it. Well, if we've seen it once, then this is now the second time that we've seen it, right? So all we need to do is say system.out.println frequency has now been hit hit twice. There we go. There. And what I'm going to do is I'm going to break out of this while loop here because I'm done. Final frequency 435, frequency 245 has now been hit twice. Right. Did I need to worry about this mapping? Did I need to worry about how big this thing was? No, because I used a smart data structure instead. Maps are so useful. You should try to get into the habit of just using them everywhere. Just like when we introduced lists, dynamic data structures that grew and shrink automatically, right? And you immediately say, okay, I'm never using a static or an array again in Java, right? Now once you see maps, okay, I'm never again using a list in Java if I don't have to, right? Because a list is nothing more than a neutered map, right? A list maps integers 0 through n minus 1 to your data. Maps, they can map anything to anything, right? You can go ahead and use a map to simulate just a regular old list, right? How? Well, let's take numbers for example, right? Where's number? There's numbers, right? Here, I'll do it in the data file here. On undo, right? That 0 is going to end up mapping to -15. Index 1 ends up mapping to -17, right? Index 2 ends up mapping to -16, et cetera, right? So in that way, a list is just a very, very, limited map, right? You're limited on the things that you can use as your key values here. So once you've gotten used to using them, you'll never go back, right? We've got 11 minutes here. Right. Any questions? No? Let's try an experiment here. Let's do this 1 billion times. Int count is equal to 0, count plus plus. If count is greater than 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, then I'll break. And what I'm going to do is I'm going to print out my frequency map. If we did this a billion times, what would it look like? So everything's getting hit twice now. Maybe a billion's too much. This is going to take forever. Yeah, all right. Let's just do a million. 1, 2, 3, 1, 2, 3. There we go. So look at all those frequencies. Most of them only got hit. Ooh, yeah. Okay. Oh, it's still going? It shouldn't be still going. All right, stop. Oh, it was still going. Why? Because it's still printing. It's not at the end here. Okay. Yeah, there's way too much there. But basically, it just kept. It probably just kept, going up and up and up and up and up. What I wanted to show was that this would go well beyond anything that we could have done over here in the C version, right? Because I made the assumption that we would never get beyond a million, right? Well, what if that assumption was not correct, right? What if we went up to 10 or 1 million millions, right? Trillions or whatever it is. And there are problems in advent of code like that. You have to be more clever about problem solving rather than just brute forcing stuff. Right? No questions, or nobody even watching online. Any questions on midterm? Or not midterm, exam 2? No? Anybody done with it already? Oh, no? All right, well, you got till midnight. You could have used this time to do it if you wanted to. All right, then good luck and have a good weekend.